everyone, this video is about solving exponential and logarithmic inequalities. 5 is bigger than 3, but if we raise both sides with the same base, for example 2 to the power of 5, 2 to the power of 3, well, the sign is the same. 2 to the power of 5 is 32. It is still bigger than 2 to the power of 3, which is 8. But if we use 1 over 2 for the base, 1 over 2 to the power of 5 is now smaller than 1 over 2 to the power of 3. And if we use logarithm, 5 is bigger than 3. If we use log 5 base 2, this is bigger than log 3 base 2. But if the base we use is 1 over 2, we get log 5 base 1 over 2 is actually smaller than log 3 base 1 over 2. So in conclusion, if the base is bigger than 1, the sign stays the same, but if the base is smaller than 1, the sign changes. Bigger becomes smaller, smaller becomes bigger. For example, we have 0.5 to the power of x is bigger than 1. So if we log both sides, log base 0.5, log base 0.5, so we can cancel out, we get x, but the sign changes. Now it is smaller than log 1 base 0.5. And here we have log x base 0.1 is smaller than or equal to 2. If we use the same base, 0.1 to the power of, 0.1 to the power of, they cancel out on the left, so we have only x on the left. On the right, we have 0.1 to the power of 2. The sign again changes because the base is smaller than 1. You can check using symbol lab. So now when we are solving more complicated inequalities, the first step is to treat this an equation. You know how to solve logarithmic and exponential equations. And the solution to the equation is the critical value. So we make sign diagram and so on, the usual sign diagram method. And remember that in logarithm, the argument must be bigger than 0. So for example, here, this is exponential. We replace this sign with the equal sign, and here we move everything to the left, and yeah, to the power of 1 plus x. This is the same as 2 to the power of 1 times 2 to the power of x, same thing. And then we can, this is 2 to the power of 2, so we can use this form. It's now a quadratic. We can factorize, and we get the values of 2 to the power of x. This is rejected because it's impossible, and this is just 1, so we get the critical value 1. So in the number line, we put the 1 here for this one critical value, and we check, for example, using 0. We can check using anything here. If you plug in 0, you plug in 0, you plug in 0, on the left you will get 4 to the power of 0, which is 1. On the right you will get 8 minus 2 to the power of 1, so just 8 minus 2, which is 6. So the left interval is rejected. For the right interval, you can use 2, you will get this, so it's accepted. So this is the final answer. Now we have this logarithmic inequality. So first of all, you can move the 2 here, so it's now x squared, and 0.25 is the same as 1/4, so we can just write it down as 1/4. And this is an equation. Now we raise both sides with the base 1/4, cancel out, and so we have only x squared equals 2x plus 8. Move everything to the left, factorize, and we get possible values of x. This is rejected because wait a minute. Oh yeah, it is rejected because you see here we have the argument just x, so the -2 must be rejected, because if you plug in -2 here, you will get an error. So -2 is not a critical value. And here from the x equals 4, we draw a number line, but remember the argument must be bigger than 0. So we have two arguments here. We have x and we have 2x plus 8. So the x must be bigger than 0 and the 2x plus 8 must be bigger than 0. If the 2x plus 8 is bigger than 0, we can just move the 8 to the right, divide by 2, x must be bigger than -4. So we have two inequalities that we have to follow here. So x is bigger than 0 at the same time as x is bigger than -4. So of course we can just use this one inequality, because if x is bigger than 0, of course it is also bigger than -4. So this is useless. You don't need this because we have this inequality. And from the from here, you put the critical value and then you check. You cannot check using 0, of course, because you'll get an error. So you have to check something using something else, and you'll get the left interval accepted. So x must be smaller than 4, but x must be bigger than 0. So this is the final answer. Another example, 3 to the power of 1 minus x. We can split this. 3 to the power of 1 times 3 to the power of minus x. This is just multiplication, by the way, so we do not expand or anything. This is multiplication. 2 times 3 is 6, so we have 6 times 3 to the power of minus x. We can move this down here, division, 5 to the power of x divided by, and we can, this is the same as to the power of 1 to the power of minus 1. So both times x, we can just factor out the x like this. We have like the power now, x, 5 over 3 to the power of minus 1. So we use the definition of logarithm. We get x equals log 6 base this. Well, this is actually 15, because 3 to the power of minus 1, that's 1/3. 5 divided by 1/3, 5 times 3, 15. So we have a critical value. And there's nothing else to check here, so that's it. You just use 0 for the left. Okay, use your calculator. You know that it's around 0.6, so you can try using 0 and using 1 to check the interval we can use. So turns out we can use the left interval. The answer is smaller than. That's it. I'll see you again next time.